You are indeed sending video. If you mean to send video, that's cool, but generally we keep this off just
All
for
right.
issues until.
All right.
All right. I don't know. Shall we start? Because we have pretty packed agenda, and I guess nobody has excuses of changing the meeting rooms, right? Walking from one room to another, stopping for cookies. So I'll do the intro slide, Brian. So welcome to the PANRG session of IETF 110. This is a Note well, which I guess most of you have seen already, but if you have not, please take a look. And by the way, the agenda should have links to all the slides, so you can click on those links instead of looking in my shared screen, because I think it might be too small. So yeah, Brian kindly agreed to keep an eye on the chat. And Jabber room should be bridged there, so we should be good here. So here is the agenda. I think we'll start with some research group business, when Brian and Spencer will give us some updates on the drafts which we are still trying to publish. And then we'll talk about path properties, and then we'll talk a bit about security and trust relationships, and we have a few drafts of interest here. So any last minute agenda bashing, any suggestions? Did I miss anything? 1, 2, 3 sold. So I guess, Brian, the floor is yours, and as far as I know, you don't have any slides, right?
Yeah, I don't really need visual aids for this point, because it would be like essentially 1 or 2 lines of text on a white screen, and you can just listen to me say those things. So since the last time we met, those of you who have been following the list have seen that we put out sent the document up to the IRSG for review, and put out a revision to address some of the comments that we got during that review. One of the so after that came in, we got a good question from Adrian Farrell, which started some conversation on the list about, okay, well, we have this kind of fuzzy idea about what path-aware networking is, but we haven't really defined path. And we'd already kind of had this problem a little bit with the questions draft, which we will speak about shortly. And how we should, fix that, sort of like the priority inversion with respect to how can you talk about what path-aware networking is if you don't know what a path is. I'd actually like to take the rest of this. I'm going to be sort of quick here so we can start early, and take the rest of this to the conversation after the path properties draft. So with no hats on other than the editor of this document, I would say the inversion is okay, because questions is supposed to be questions, right? Like, and what is a path? That's a perfectly reasonable question. However, if we think that there's sort of like a semantic issue with trying to define the questions without defining the terminology for those questions, I think the right place to address that is in the discussion on the path properties draft. So that's where we are on questions. I'd like to have a little bit of that conversation today, take it to the list, take the outcome of that conversation, turn it into an updated version of the questions draft to send out for sort of another round of discussion, and then we can get it published. So if anyone has any particular questions or points to make about that plan, we should discuss that now. Otherwise, I'd say we follow that plan and use sort of the remainder of my time after the path properties discussion to discuss sort of like next steps with the what is a path question. Any meta questions? Cool, moving on. 6 minutes early, let's go to Spencer.
Okay, let me get slides for Spencer. Just a second. That's what I'm doing. Okay, second. Okay, you. Okay, Spencer, just let me know when you want me to move to the next slide, please.
Yeah, thank you. Thank you, Jen. So I'm doing the yeah, just about that fast. Doing the update on where PAN what not to do has been since it left the research group. Next slide, please. We've actually been kind of busy. We've gotten comments, and these have been most of these have been non-blocking comments, like especially the ones from the ISG and things like that on that where we did -17. And all of this stuff has been on the mailing list previously, but the ECN stuff was just submitted this past Monday. I'd posted text previously, but it's good for the research group to see what I'm actually saying. So next slide, please. So Martin said, why not ECN during the IETF ISG conflict review? And the easy answer was nobody contributed a section on ECN, but that seemed kind of lame. We aren't actually covering everything, but we wanted to cover all the lessons. And after I talked with Brian a bit, ECN did actually have lessons learned that weren't covered elsewhere. So I wrote a section on ECN and updated the lessons learned in the draft. And I want to do a shout out to Sally Floyd's ECN page, which was still active and very helpful. So like I say, submitted -18 on Monday with the text that I had sent to the mailing list previously. And next slide, please. Yeah. So what was different about ECN was that these guys did so much right. Lessons from our doc, which hadn't been written yet, thinking about incremental deployment and impact on router throughput and trust issues between the node and the network, but they didn't anticipate that routers would flat out crash when you sent non-zero ECN bits. And this was actually I want to do a shout out to Dave Thaler and his team at Microsoft. They did a presentation, which is referenced to the draft, about this, and basically said, like, this is one of the more duh comments I've seen at an IETF. They said, if you crash the router, you can't recover that at the TCP layer. So they shipped Vista with ECN turned off. Because the router that was crashing was a popular model from a popular router vendor. And once you've turned it off, you really don't have much incentive to turn it back on. And that logjam can persist for a decade or two. People are starting to turn ECN back on now, but I mean, this is from, like 10 or 15 years later. So the lesson learned that I took away from that experience was sometimes you get one chance to get it right. Next slide, please. So my questions are, did we do the right thing by including this contribution? Because this is significant text late in the process that the research group needs to see. Martin Duke asked, is there a better way to describe the ECN lesson than just one chance? So I'd be interested in hearing things about that. And we talked, and I talk more about this in my next presentation, but we talk about whether lessons are invariant. So, well, and that's what my suggestion was, well understood and likely to be applicable to any PAN solution. So my suggested path forward is to get comments on the mailing list due in 2 weeks after IETF, and then I submit a -19 reflecting those comments for final approval by Colin, which I believe is the last stop for us. So I should, a good question to ask is, has anybody looked at this text? Probably. Um, um, Brian, I see you in the queue.
So yeah, as an individual, I have looked at this text. I think it's good. I would say I would make like a tiny little nit here is like, is there a better way to describe the ECN lesson than one chance? Well, I mean, it wasn't one chance. We're doing it again. It's possibly one chance every 2 decades. Where that 2 decades is a real number, right? Like, so there might be something to say about sort of like equipment replacement cycles. Like if you have to forklift hardware, it's going to slow you down. But that's like would be a minor point to make there. I think the one chance is a good characterization of it. But yeah, I think this is a good plan forward, again, without my hat on.
Cool. Thank you. Thank you. Looks like Mr. Gorey.
How many buttons can I press at once? Whoa, does that work?
Yes.
Oh, except it says arrow video closed, which is really cool. However, you don't need to see me. So it's great, Spencer. I now have an opportunity to say I haven't read your text, but I still have an opinion.
Welcome to the isn't that an IETF thing?
Okay, but it's the same as Brian's. I think we need to be really careful to say it's one chance per equipment lifetime, and really call that out, because otherwise it sounds like you're talking about a dead experiment. Because if we talked about ST2, we would say no, it's gone forever. Whereas for this, it's not really gone forever. The bug came because somebody read the TOS byte from a spec which was 10 years old when they did the device. So they were from a previous generation. They put the bug in theirs. It lasted for a generation. Yeah, there's something about generations here, and I will read it and give you some proper comments. No problem. And let someone else talk.
Oh, okay, I'm here. Yeah, so thanks, Spencer, for taking my late comments. I wouldn't disagree at all with the like accuracy of the one chance and one chance per equipment cycle or whatever it is that people want to put here. My point is a little more meta than that, and then I don't understand how this is actionable to protocol designers. I mean, does this just increase their stress level because if they screw up, like they're doomed? Or is there something you can actually do? And I think we talked about this a little bit on the thread. And I wasn't there, so I can't comment if there's something they could have done to avoid this router crashing problem. And I think the immediate feedback I got last time I checked was that no, there was nothing they could have done. There was a lot of testing, and somehow this happened. But I wonder if there's a way we could be more constructive than this in terms of providing guidance to future efforts.
If I was going to try to wordsmith this on the teleconference, which I would not recommend, I would probably be thinking in terms of something like a broadening. Basically think outside the box on the tests that you run, because they tested this stuff, just obviously not with that router. And so things got awkward when that router was in the path. So, like I say, let's talk about that on the mailing list. But thank you for the comment. So is this Colin?
It is Colin. Yes. Can you hear me?
I can hear you.
Yes. So thank you for doing the update. On the point of view of sort of release cycles and so on, I mean, I think the comments about once per sort of equipment life cycle makes sense. I'm wondering if there's something which can be something that can be said about structured approaches to testing, because certainly when people came to trying to deploy ECN again for the second time, my impression is that, and I guess it was Apple that were pushing it, they followed quite a careful approach to to pushing out this in an incremental way in small numbers of devices, whilst also working with the operators to address problems. And there's maybe lessons that can be learned from that.
I think that's a good. I think that's a good. I think that's a really helpful observation. Just the thing where even being able to roll operating system revisions, which happens, like every quarter these days on a lot of hosts, rather than every equipment cycle on a lot of hosts when ECN was deployed the first time. But I think that's a very helpful suggestion to think about what's changed since we since ECN was attempted to be deployed the first time. Thank you, Colin.
Thank you. And just in terms of the comments, for final approval and so on, as soon as the research group's happy, I'm sure I will be happy.
Fabulous. So does this get us to Gory?
Saying what I want to say. Measure before and test gently as you're deploying, I think, are the two things we need to do. So we're getting better at measuring before with much bigger experiments, but we're also getting much better at testing during that initial deployment to see whether this is actually a showstopper. If they'd seen that very early on, they would have stopped doing this and we'd have fixed the problem.
Yeah, I think, like I said, I think it's very helpful. Thank you, Gory. Does that get me to Eric? Hi, Eric.
Wait for our little audio bounce. There we go.
Yeah.
Just real quick,
I think
we're going to close the line after Jake now. So I love talking about ECN as much as the next person, but we do have to get to the rest of the.
To Martin's comment, I think there is something that's actually actionable that we could include here, which is, and I agree with a lot of the things about doing it incrementally and working with operators and making sure that we can measure as we go, and those are all good things. But at the end of the day, having at least where possible, having a fallback strategy or some way to ensure that the end user pain is mitigated in the event of a problem, likely in this and many other cases ends up being the key to whether we end up turning something off versus being able to keep it on while things are being fixed. And so had we, now that we know that there were a lot of problems, we have all sorts of interesting strategies and heuristics that we can use to say, this looks like a place where somebody blows up when we use ECN, but pick anything that we're doing, which is part of why we have this document. And we can do things to try to either detect in the moment or remotely disable it or handle that sort of a situation. And so it's great to measure, it's great to be able to coordinate with people, but fundamentally, if we measure and we discover that there's a big problem, we still end up in the same bad place. So if we measure and we detect that there's a problem and we are able to prevent that problem from causing users lots of pain, then we can end up in a much better place. So that might be an actionable thing that we could put as rather than a don't screw up your protocol is like kind of hard. But think about the failure mode and design a way to remove the user pain from that failure mode might allow things to be much more deployable.
Cool. Thank you so much. Gets me to Karidi.
Hello.
Hi, Karidi.
Yeah, hi. I just want to echo some of the comments that we heard. One is, I like what Eric just said in terms of not just test, but have a plan B, have a fallback plan. But I actually want to go back to Colin's comment and your response to it, which I liked, which is the generation. That whole thing that someone said, is this to increase stress? Generations are reducing the length of a generation Because if you have microcode, you can fix things a lot quicker. If people are updating OSs quicker, then you can fix things quicker. So the fact that it's a generation doesn't mean it's a it's not 10 years anymore. It's not that long. So not to take anything away from what you're saying here, that we should be careful, and in many cases it is one chance. The main thing about the one chance is not the generation as much as the taste left in your mouth if something goes wrong, and so your reluctance to retry it. And so we really have to, and that's why I appreciate Eric's comment, because if you reduce the bad taste from an experiment that goes wrong, then people will be more likely to retry it. I think that we have to be careful that from 20 years ago to now, the generations have become a lot shorter, but the bad taste and people's reluctance to try things a second time is, I think, the bigger lesson here. Thank you.
Thank you, Kriti. It gets me to Jake.
Yeah, hi Spencer, thanks. There's one, I agree the protocol designers did a good job, but there's one thing I really think would have been better, which is if ECT1 was NECT. So they went ahead and defined it without, and gave it a meaning without making it different than the one that's there. And this has caused trouble that's still unfolding today. If it had been NECT for ECT1, meaning keep doing what you're doing before, then some of the current discussions would have been just a lot smoother, it seems like. There's a, I don't know how you fold that into a generalizable thing, but when you're bringing up ECT, it might be worth mentioning in terms of future compatibility.
Cool. Thank you, Jake. So I have some comments now. If people have other comments, you have 2 weeks, not counting this week, to send them in, and then I will submit that, copy the research group, and let Colin do the right thing, if that works for people. And thank you all for your input. Next.
Okay, since Spencer, we are a bit over time, so yeah, Teresa, the floor is yours. I'm getting the slides in a second.
Hi, can you all hear me?
Yeah. Yes, I can hear you.
Cool. Hi, I'm Teresa. I'm presenting an update on a path properties draft. And yeah, next slide, please. So we have published 2 revisions, and one was basically just addressing some minor feedback points. And now the most recent revision sort of speaks more generally to the purpose of this draft, because there was a lot of discussion on terminology in both the questions and the what not to do draft during the sort of way to publication. And so we are thinking that, yes, we need a generic terminology. I mean, we know that that's what the path properties draft is for. And our hope is that this terminology in a draft can be useful for PANRG to use in the other drafts and to discuss path awareness and path-aware networking in general. And then the what not to do draft, right, has a lot of specific terminology. So we were thinking, okay, we have a generic terminology, and now a specific technology would consider specific path elements. So, right, we define sort of an abstract or a general path element, but then a specific terminology would say, okay, we are talking about IP routers and have their own definition of path element. And then they would sort of make their own definition of a path and define what path properties they consider and also what they can do about their path, right? So we hope that our terminology is already sort of generic enough to cover those relevant concepts and to be potentially applicable to path-aware technologies that we talk about in PANRG, which includes past, present, and future technologies. But yeah, I wanted to know if people think that our terminology is already there, or if there's anything that you are still missing. And that is my first question. And then I have one more slide. Okay, and if there's no feedback right now, we can also move to the next slide now. So in addition to that generic terminology that the path properties draft provides, it also has a use cases section and an example section. And so here we thought, okay, so we have a definition of paths and path awareness, and now it would be good to have some motivation of why somebody would even care about path properties, and that is part of why the use cases section exists, right? So we have 3 use cases: path selection, protocol selection, and service invocation. And we think all those use cases are generic as well, but then a specific technology, again, would sort of have their own flavor of path selection, right? It can consider different path elements. Maybe it selects between different routers that it knows about. Maybe it selects between different networks that it knows about, and then this principle, this use case of path selection would sort of apply to specific different terminologies, and it's useful to explain the general concept. And so that is the use cases section, and then we also have examples of path properties, and here again we have, okay, this time I guess the examples are rather specific. We reference specific RFCs, for example, for some performance properties, but still it's, again, it's illustrative of what you can do with path properties. And so we are also wondering if there's any specific use cases or examples that people are still missing from the path properties draft, because we would like to get it closer to publication to have a stable reference for other drafts. And that is actually all I had for slides. And now I'm hoping for some discussion. Brian, you want to go first?
Yeah. Hi, Teresa. How you doing? You'll note no hat. This is the chair hat. It's over here. So I as a non-exhaustive list, I like this as a starting point. It's sets the use cases up into pretty broad categories. The one nit that I would have is that we should probably be pretty clear that service invocation in this case refers to service as defined in sort of like the service function chaining context, and not with respect to sort of like endpoint services. Maybe I just see this because my day job is compute these days and not networking. But I could certainly see service invocation and service selection being part of the path property thing, right? Like, so you have a front end that's going to steer to a different back end based on the properties of the path on the other side. And that would be a different kind of service invocation than the kind of service invocation that you mean. And the kind of service invocation that you mean is actually more important for the PANRG context. So I'd be a little bit more, yeah, that's the problem with this whole document, is that every word we want to use is already contextually overloaded. Back to the previous question, I think that this is actually a good split as well, by basically saying we're going to try and build the abstract framework, or the abstract meta terminology as a way to build the concrete terminology on top of it. I think this is a good approach. So yay to all of the changes up to -02 from me.
Thanks.
No.
Okay, Jake.
Yeah, hi, Teresa. I just wanted to say I've been meaning to write an email. I will get it out. There's a couple of examples that I think are relevant to this question. It's actually, I had tried to do it as a follow-up to Michael Welsel's request to talk about sort of discovery of on-path stuff. I think there's a few things that I've been looking at that are in a relevant direction here, that actually Brian's comment made me think I'm not quite sure if I'm talking about the same thing that you're talking about, but I will send that email. I will get it out. So look for that within the next couple of weeks.
Thank you.
Hopefully.
And yeah, I also appreciate comments via email. And or we also have a GitHub. Maybe we should talk about making it a PANRG GitHub. Now that the draft is adopted.
Okay, great. I do not see anyone else in the queue, and we're getting back on time. Thanks, Teresa, for getting it short. So next presentation will be about the path property.
Jan, I wanted to,
yeah, sorry, Brian.
I did want to jump back in the queue really quickly to go back to the questions question, right? Like, so there is a standing question as to whether we want questions to have a normative forward reference to path properties for the definition of a path, or whether we want to try and leave it open. So I would have a question for Teresa before we, yes, thank you for coming back, is in terms of like when we think we might be able to publish this, does it make sense in your mind as the editor of this document to maybe take all three of these documents and push them out together? Or should I, as the editor of questions, try to cut, like, you know, go back to sort of like the abbreviated, super abstract version of path, so that we can get them out the door and put them in, like, you know, a directed acyclic graph of references. So I'd like to get your opinion on that.
Okay, so my initial reaction is that the path properties draft answers the first question from the questions draft. So it feels kind of silly to have a reference to the answer draft as a normative reference. And I'm not sure that it's actually needed to have this kind of clear, rigorous definition. I mean, I don't think it's necessary to have the first question already answered in order to publish the questions draft.
Okay, cool. So I will take that in answer to Adrian Farrell's email, which I'm now noticing was like almost a month ago. So I got to get on that, but I will take that to the list. Thank you very much.
Sure.
Okay, Spencer, are you in the queue? Okay, we'll close the queue after you, but yeah, I guess go ahead.
Yeah, I just wanted to say real quickly for the research group that we ended up I have a informative pointer to the terminology draft, but I do not. Most of the contributions were done with a range of definitions of what people thought path-aware networking was, or whatever it was they were doing at the time. So that question is not active for that question is not active for what not to do. It's only for the research questions draft. Thank you.
Okay, great. Sharon, are you here? The floor is yours.
Hello?
Hello.
Hi. Anybody can hear me?
Yes, we can hear you okay. At least I can hear you.
Hello? Oh? It seems like I can't hear.
We can.
Hi. Hello. Hello.
Yes.
Hello.
Yes. Can you hear us?
I can't hear it. I don't know if anybody can hear me or it is me have any trouble with my connection. Okay, but I can't hear you, but maybe I will just start.
Maybe you can.
Since everyone can hear me, maybe I will just start.
Maybe you can Mm, eh, okay, yes.
Hello everyone, this is Zhen from China Mobile, and this draft is about the required path properties for applying path-aware networking in integrated space-terrestrial networks, and maybe it can be seen as an input for Teresa, and hope it can bring you some inspirations. And yes, if you go to the next slide, please. For this slide, it is about the relationship between the ISTN and the space and the path-aware networking. Basically, I just listed some characteristics of ISTN and PAN, and we can see whether these characteristics match well. And for the first bullet, it is about the limited resources, and because of the source of the satellite is the solar panel, so the power of the satellite is always limited, and so does the computing resources and storage resources. But by taking advantage of the PAN, maybe we can leave the complicated calculations or the selections, all these functions to the endpoint and make the network node as simple as possible. And for the second and third bullet is about the cross administrative domain and cross layer, because it is quite possible that the ISTN is a cross administrative domain and cross layers, while the PAN is very suitable for those kind of networks. And for the first bullet, it is about the multi-passes characteristics. The ISTN can be seen as a native multi-pass network, since both space passes and terrestrial passes can be used to transmit traffic, and a PAN can just take advantage of these features. So it seems like the path-aware networking is suitable for ISTN and may help to cope with some challenges of the ISTN. And then if you go to the next slide, we can take a look about the use cases and the challenges. Yes, this is a very brief picture about the use cases, and in our understanding with the development of the space technologies and the satellite capabilities will be stronger, and therefore the satellite can be integrated into terrestrial networks as a router or as a server, and can be seen as part of the access networks or core networks or even a data networks. Then the use cases will be more complicated than we thought. So there are many challenges we need to be take care of. For example, you need to adapt to the time variant topologies due to the mobility of satellites. You need to adapt to limited resources, as I explained before, and you need to adapt to various link characteristics, especially the space links, which may have unpredictable link failure, and moreover, all these links maybe will use totally different protocols. So it seems like so many things need to be done to handle these challenges. And when it comes to the PAN, it will have some additional requirements on the path properties. And if you go to the next slide, please. Yes, here I list the requirements on path properties in ISTN. And as you can see, we believe that the path properties can have two granularities. And for the coarse granular, it may contain the path properties, and for the fine granular properties, it contains the node properties and link properties. And some additional path properties are dedicated in space networks, while maybe others are common properties in both terrestrial networks and space networks. And because I only have 5 minutes, so I won't go through all those properties. But if you have some interesting, and you can maybe find it in the draft. And if you go to the next slide, please. Yes, it is just a brief summary. The integrated space terrestrial networks can take advantage of the PAN and thereby can be seen as the typical use cases. And when the PAN is applied into the ISTN, the additional path properties may be required. And thanks for listening my humble view, and hope it will be helpful, and any suggestions are welcomed.
Okay, so I guess you cannot hear us anyway. So I suggest we bring the discussion to the chat then. In the mailing list, sorry. And because, yeah, we're again running overtime, I suggest we move to the next presentation. Thank you very much for presenting this. I am getting the next slides. Juan, I am getting your slides in a second. Infrastructure. Sorry, I am so slow. Review and share screen.
Thank you, Jen. I guess you hear me well? I think so.
Yes, I think we can hear you well.
All right, thank you very much. All right, so I'm Juan Garcia Pardo.
Wait.
I want to have a... There we go. So, yeah, since this is going to be a very short presentation on DRKey, so the dynamically recreatable key infrastructure. So I'm going to try to keep it in 10 minutes. So the idea, if Jen, if you can go to the index, so let me quickly just, yeah.
Yeah, sorry.
Yeah, fine, thank you. So I'm just going to introduce an example very early, so I think it will be understood what later, or what DRKey can be used for in the context of source authentication. And later on, because we want to introduce EPIC as a path verification system later on also into the PANRG, we thought let's give it a spin first into the DRKey, which is like the basis for EPIC. All right, so the after the example, I'm just gonna talk the minimal about the key hierarchy in the DRKey, and then some details about the derivation and exchange. So if you go to the next slide, please. So what is the DRKey? The DRKey is just a protocol for establishing and exchange symmetric cryptography keys that can be used for authentication. And any autonomous system that wants to opt into the DRKey protocol, they will have at least one key server. This is just an entity that understands the DRKey protocol. So the DRKey was designed with scale in mind. To scale with the internet, and since we cannot keep state for every possible entity that would like to be authenticated into the internet, the DRKey doesn't rely to keeping state for that much or for that many entities. So there is this key tree that we'll see later into how that's used to derive the next keys and so on. The configuration granularity is up to the autonomous system level. So once we see the key exchange, we'll understand that some key servers can deny requests to whole autonomous system entities over there. Next slide, please. All right, so I have to introduce these key levels already, because otherwise the example will not be understood. There are 3 levels, key levels, level 0, 1, and 2. The level 0 is also called the secret value. There is just a key that is originated into 1AS. the owner of that key, and it's always kept in secret inside that key server. That is the key used to derive the level 1 keys. Those are the AS to AS keys that could have logged the protocol. In this context, the protocol is just the purpose of that key. So for instance, to authenticate DNS request packets, let's say. And this is just a string of bytes. And then the level 2 key is derived using the level 1 key. We'll see the details in the key derivation very quickly. And then that's the actual key that is used to tag the packets, to compute the maximum on those packets. So every key has a validity period that is inherited from the previous level, and the level 0 is the actual level that establishes the validity. And then every entity that is part of the communication will derive that key in either of one of 2 ways. So the owners of the key can derive it in nanoseconds, and any other entity which is not the owner of the key on that AS will have to obtain the key via their key server, and then we'll see how that actually works also very quickly. Next slide, please. So this is just a picture to remind that the level 0 key never leaves the key server, and we're seeing at the same time the same key. So this is the level 0, 1, and 2 keys for the same key. And then the level 1 key lives in both key servers because that is the one that is exchanged. The level 2 key is the actual key that is used to authenticate. Next slide, please. So as an example, we're going to have a DNS server that wants to authenticate every packet that receives from end hosts querying it. And then this server is going to be trusted by the key server for certain protocols, certain uses. I just called it DNS. It could have been DNS source authenticated, whatever. It's just a string that we have agreed upon. And then if you go to the next slide, we'll see the sequence of events that are listed over there. It's just a very quickly. So we have, we have just a sequence on ASA on blue. On the left side, we have the DNS server that is our guy that actually requests to get the level 1 key to the key server, because the key server has configuration saying that that end host in particular is authorized to get that key. They return that key to it. Then on the right-hand side, we see green, the end host at B that wants actually to communicate with the DNS server, and then for that they need to get the level 2 key to talk to that end host in particular. So they will ask their key server, please get me that level 2 key for me, because they actually cannot get it. And then the key server checks if they have the level 1 key for that other AS. They do. In this case, we'll have another example where they don't, but this one they do, and they can quickly derive the level 2 key, which is returned to the end host. Then that end host from that moment on can start using that level 2 key, using symmetric cryptography, or just computing the MAC, for instance, to start creating tags for their packets, which arrive at the DNS server, and they know that that packet came from the ASB end host, whatever end host this is, and so they can quickly derive the level 2 key on the fly, and they can validate that tag. We'll see concrete examples maybe later if there is time. Next slide, please. I'm sorry, I have to rush a bit because otherwise. All right, so this is just a recap for later for the record of what we just talked. I don't think that we have to go through everything that we just said. It's just that the key points here is the level 2 key is the important key. That's the key that is used to actually authenticate the packets. The protocol can be locked already in level 0, but if it's not locked in level 0, it has to be locked in level 1 or level 2. So there is always a protocol locked at the very end, at the very last, at the very least, sorry, at level 2. Next slide, please. All right, so again, let's just look at the last paragraph. So the important part is just that the level 2 key has to be obtained by both parts of the communication. So there is a fast side, which is the owner of the key that can derive that level 2 key very quickly. And they don't need to do anything special. They just need to know who is the other guy in the communication. While the slow side, which is not the owner of the key, they cannot derive it very quickly. So the communication, so the packet flow, it can go both ways, from A to B or from B to A, but the slow side will have to get the level 2 key beforehand. Or if they receive a packet that they don't have it, they have to queue that packet to be source authenticated later. This asymmetry Well, it's kind of important, isn't it? All right, so if we go to the next slide, and then I will just conclude with the key derivation. All right, so the key derivation, there are two key derivation functions or flavors. The first one is to derive the level 0 key. That's the slow one, but since we only do it once per validity, per period, per key period, or key validity period, that's not so important. We're using the password-based key derivation function 2 with 1,000 iterations of SHA-256, and that's done only once again, and done only in the key server of DataES. And then the level 1 and level 2 keys are using a much faster pseudo-random function, is AES CMAC. The details are explained later also in the slides and the paper and so on. So the important part is that the level 1 and level 2 keys, as we have said already, they are very, very fast. This is just the last point is just a clarification in the nomenclature, because sometimes it can be difficult to read. So that key proto x2y means that there is a DR key which is locked in the protocol proto, and has a fast side or owner of the key X, and the other side is Y. And X and Y can be AESs or end hosts, depending on whether we are talking about the level 1 or level 2 keys. If we go to the next slide. Yeah, the level 1 keys, so the AES to AES keys are the ones that are propagated to the other key servers, and we'll see an example of the propagation of the exchange. So since the communication has to be signed and encrypted, in the case of, for instance, Cyan, the Cyan architecture, we're using the control plane PKI. In the current IP internet, we could use RPKI, for instance. There's configuration of the key servers that could deny, as we had said before, up to the AES granularity level, level 1 key requests. And that could also happen for level 2 key requests within the AES. If there is the possibility of locking, as we had said, the protocol or reading the secret value, that allows the fast side not to have prefetch the level 1 key for the other side as well. All right, so just if we can go to the next slide, please. This is just my last slide. All right, so we have in the middle in blue the ASA, which is the key server that wants to propagate, or the key that wants to be transmitted to the other key servers. So we have the first thing is in the key server B wants to prefetch that level 1 key, makes a request, key server A checks it, and then returns the key, of course, no problem. And then later on, an end host in the ASA wants to obtain the level 2 key, as we had seen in the DNS server example. And then in this case, the key server doesn't have the L1 key, which is requested to the key server .A, but the permission to the AES is not granted. And that key server C is just answering there was a denial of that key, and then the end host doesn't get that one. All right, so if we go to the last question, last slide for questions. Also, if anyone is interested in this presentation, the next slides, we have references and mock-up slides, because, yeah. Thank you.
Yeah. Thank you very much, Juan. I'm just afraid because, yeah, we're running over time and we have 2 more presentations. I suggest, so we bring the discussion to the mailing list. Thanks a lot. Spencer, I'm getting your slides in a second. Okay, sure.
Yeah, thank you. I just wanted to put that quote up, and then next slide, please, Jen.
Okay, my computer, okay, here we are.
Okay, cool. So my computer just did something, but it stopped now, it looks like. So this is what we have in the table 1 in the What Not to Do -18 draft. And we were basically saying how, what do we do with the different lessons that we've learned? And two of them were not now, which are this characteristic tends to turn up a minefield full of dragons. With the rest of that caveat, one is endpoints trusting intermediate nodes, and one is intermediate nodes trusting endpoints. Next slide, please. Not now. I'm trying to figure out if not now is actually not ever. So one of the things that other people have observed, hi Adrian, PANRG has been focused a lot on end-to-end transport. And the conversations I've had about that, and this is a quote from an ISG offsite, was if we could send packets with no source and destination addresses, we would. But I observed that there are network elements and hosts that trust each other, in addition to network elements and hosts that don't, which is true of pretty much all the elements and hosts in the IoT Ops POF that happened earlier this week. And I wanted to call out Elliot Lear's presentation there as something that was really clear on helping me understand that. And that I have observed people that want to exploit trust, and I mean that in a good way, like starting with the next presentation. Next slide, please. So my questions, and this is going to be for discussion on the mailing list or for an interim, which is starting to look like a better and better idea as we talk, is trust always going to be a mindful field full of dragons? If that's true, we should write that down and say, and basically tell path-aware networking designers, don't go there. If we think it can be usable sometimes, we should write that down too. And think about what are the prerequisites for path-aware trust. I mean, between the host and the first hop nodes is an obvious case. Between intermediate nodes is an obvious case. Even between networks is horrifying. But I mean, people try to do these things. And my question is, next question is, how do we avoid tripping over the lessons that we've learned? If trust is usable, what else needs to be true in order to achieve deployment? This is getting into a meta question about, are we ready to start on a PANRG what to do draft, which people have been asking for a while. And next slide, please. For example, in some of the ones that I'm looking at right now, I'm especially interested in these lessons learned, and especially the one that is invariant, which is basically saying, this is always going to be true, and you need to have a really good story for the impact on operational practices. But that's not to say that the other lessons learned are not interesting, but it seems obvious to me that the lessons learned are useful for us to be looking at different proposals, both here and, as the ISG said, in the IETF. That's my last slide, I think. So onto the mailing list, right?
I am afraid, yes. I know it's good. I would love to hear the discussion, but looks like we made a mistake by scheduling just 1 hour. Brian in the queue. Okay, Brian.
There was a suggestion that we actually try and do an interim before 111, which I think is probably not a bad idea. And I'm wondering if we want to just use the next minute to have a quick intro to the next talk, take this discussion to the mailing list, and pick it up in a couple of months at an interim.
Works for me. Thank you.
Okay, I am getting the next presentation ready. Just a second. Okay. Sorry, I am not very effective in 2:30 AM. Verification window. Share this one. Okay.
Can you hear me?
Yes, we can.
Thank you. I'm Song Pengdu from China Mobile. I want to share this gateway-based trust relationship between the endpoint and the intermediate node. Second, next page, please. We found two problems. The first one is that if the endpoint gets some information from the network, can it trust the information? And the second one is if the endpoint gets some suggestion to the network, can the intermediate node trust the suggestion or trust that it is from a valid user? This is our two problem. Next page, please. Normally, we cannot assume that they can trust each other because we found the reason is that the endpoint can support this layer 4 connections, and the network only supports up to this layer 3 packet forwarding. It's hard to establish a trust relationship between them because they work in the different network layers. Next page, please. And in our observations, we found that the gateway of the endpoint is able to maintain a connection state and a trust relationship for each user, such as this PNG. It means a broadband network gateway. And we also found that the ingress PE perhaps is a main node to select the path for the flow. So we think that if we cannot make every intermediate node trusted, perhaps we can make this BNG and the intermediate ingress, this ingress PE trusted. Next page, please. We have a initial solution for this. From the ingress PE to the client, we can make this ingress PE insert some signature for the message, and from the client to the ingress PE, perhaps the ingress PE cannot maintain a very client status, so we let this PNG make a signature instead. So or we can put this traffic into a seg between this BNG or this ingress PE. This our potential solution. Thank you. I think that's all. Thank you. Any comments?
Okay. Thank you very much. And I suggest again that we bring in comments to the mailing list because we are run over time, and as far as I know, the session could automatically shut down. So thanks a lot for presenting this. Okay, thank you very much. I'd like to thank Jake for taking meeting minutes, and I guess, and as Brian mentioned, we probably will do interim, which are looking at this. All those discussions we have to bring to the mailing list sounds like a brilliant idea. More and more with every minute.
Yeah, let's take all of that to the list, and we'll reach out sort of like the next week or the following week on starting to schedule an interim. We'd want to do that between now and San Francisco, which is sort of the end of July. So we'd probably be looking at like a late May, mid to late May, early June, but we'll find something that works in a time zone that works for the participants as well. I know this was super late for Jen and super early for everybody on the West Coast of the US. So we'll try and find a different slot for that as well. So thank you all for your attention, and thank you to the presenters, especially for going fast. And we will see you on the list and at the interim.
Thank you. Bye.
Thanks. Bye.